All right, in this video we're going to talk about what linear combinations of vectors actually are. This is sort of a fancy way of manipulating vectors to cause all kinds of different things to happen. As far as exact examples of why you would ever want to do 7 times a vector minus 2 times another vector, just keep in mind that there are a lot of things in the world where you have baseline values that you can then modify or adjust based on certain things. So maybe there are 7 creatures or people or things that are applying a certain pressure and 2 other people that are doing this other pressure or value. It's really loose. This is intended to be an abstract, skills-based video. I'm not going too deep into where and why this is being used, especially because here in a moment you'll realize that I've rambled longer at the intro of this video than I would have needed to if I had just wanted to work this problem out. This is a very fast problem to do. If you've watched the previous videos that I've talked about with scalar multiples, you'll realize that all we're going to do here is actually multiply these things together. So like, for example, here, 7 times this vector A and negative 2 times our vector B. And then we're just going to add those results together. So for example, 7 times A would be 28 and 63. And then we're going to add to that negative 2 times this, which is going to give me a positive 4 and a negative 28. And you might go, well, hang on, it was subtraction here, but I'm thinking about this like a algebraic problem, so I distributed the negative 2 to both of these guys. That negative went along with it, which in turn left me with the positive here instead. If you don't like that, then leave this as a minus sign. That would make this a negative 4, and that would make this a positive 28, and you would get the same result that I do when you actually subtract them instead. But here I'm going to do 28 plus 4. So 28 and 4, that's going to give me a total of 32. And then here, let's see, 63 minus 28, that'd be what, 35? So 63 minus 28 is 35. If you don't trust that, go grab a calculator, you can find out. But this is it. I mean, really the work behind these types of problems is very basic. It's very straightforward. As long as you're comfortable either grabbing a calculator to help you with the numbers or just running them very carefully yourself, you can pretty easily throw these things together. I would not encourage too much in the way of sketching problems like this one, simply because these numbers start to get kind of large. You're kind of drawing 7 copies of 4s and 9s. I mean, if you're trying to visualize this one, you can. You can take the time to do it. But I don't think it helps you in this case really get through the problem because they've already given you your x and y components, and that's usually what I'm trying to find when I graph a vector. I like to use vector graphs to find those x and y components. So if they're given, just use what they gave you. If they're asking you to find some kind of weird combination like this, just think about it like a distributive property and then just add these things together, and that's all you've got to do. So there you have it.